In the previous video, we had seen about the convolution theorem, proof, and based on a convolution integral, the problems. Now we will continue with your convolution theorem problems. So first is we are going to see find the convolution of h of t is equal to t and f of t is equal to e power minus alpha t for t greater than 0 using the Laplace transform techniques. So here now we are going to have your convolution formula. First we are going to find out your h of s, then your f of s. So we know that your Laplace transform of your h of t convoluted f of t is equal to h of s into f of s. So here in this case we know that h of t is equal to t and Laplace transform of h of s is going to be your 1 by s square. And next is your f of t function. So f of t function is going to be e power minus alpha t. So Laplace transform of your f of s is going to be 1 by s plus a. So f of s is 1 by s plus a. So now we know that it is h of s into f of s. So h of s into f of s is going to be your 1 by s square into 1 by s plus alpha. So here when I am going to get your function is going to be like this. So when the function is going to be like this, your h of s is equal to 1 divided by s square into s plus alpha there. So here if I am going to apply my partial fraction method, using a partial fraction method, this is h of s into f of s. So to find out your convoluted value, h of t convoluted f of t, what we are going to do is we are going to apply the inverse Laplace there. That is a partial fraction method. So a partial fraction method is going to be your a by s square plus b by s plus c by s plus alpha. Okay, so in this case here we are going to have it as your, if you take your so in this case if I am going to take my this one, it is going to be a into, so your numerator is going to be 1, so 1 is equal to a into s plus alpha plus bs into s plus alpha. So here in this case this value will be bs by s. So here your so it is going to be your a into your LCM is going to be s plus alpha plus b into s plus alpha plus c s square. So now if I am going to group it out, you are going to have your expression to be 1 is equal to as plus a alpha plus b square plus bs alpha plus cs square. Now this is a constant, so constant is 1 is equal to a alpha. So that means that a is equal to 1 by alpha there. Next is your s square term. S square term is nothing but b plus c is equal to 0. So now s alpha term, if I am going to see equating your s terms, it is a plus b into alpha is equal to 0. So we know that a is 1 by alpha. So I can write b alpha is equal to minus 1 by alpha. So that means b is equal to 1 minus 1 by alpha square. So now if I substitute here, c is equal to 1 by alpha square. So that is what we are going to get here. So we have your function to be your a is equal to 1 by alpha, b is equal to minus 1 by alpha square, c is equal to 1 by alpha square there. So next what we are going to do is we want to find out there. The h of t convolution f of t is equal to Laplace transform of a is 1 by alpha by s square minus 1 by alpha square by s plus 1 by alpha square by s plus alpha. So if I take the Laplace inverse, 1 by alpha into, it is 1 by s square, Laplace inverse is going to be t. So we write it as 1 by alpha into t minus 1 by alpha square into t plus 1 by alpha square into e power minus alpha t. So this is your h of t convoluted f of t function there. So here we have it as, that is your first problem there. So this is s square, this is going to be your u of t. So u of t is going to be here 1. So here in this case, this value will be 1 there. So 1 by alpha square into 1. Next is we are going to find out the convolution of a h of t into your h of t is e power minus t and f of t is going to be e power minus 2t. So the solution is going to be your h of t. H of t is going to be e power minus t. So your Laplace transform of h of t is 1 by s plus 1. Here we are going to have f of t. F of t is going to be your e power minus 2t. So e power minus 2t is f of s is equal to 1 by s plus 2. So 1 by h of s into f of s is equal to a by, so it is f of s into h of s. H of s is going to be 1 by s plus 1 and this is going to be 1 by s plus 2. So we can write your h of s is equal to your h of s into f of s is equal to 1 by s plus 1 into s plus 2. So I can write it as a by this, I can write it as a by s plus 1 plus b by s plus 2 is equivalent to 1. So I can write here as a into s plus 2 plus b into s plus 1 is equivalent to 1. So here it is your as plus 2a plus bs plus b is equivalent to 1. So now if I am going to see equate the constants, your constants are going to be 2a plus b is equivalent to 1 and a plus b is equivalent to 0. That means your a is equivalent to your a1 is equivalent to a into s plus 2 plus b into s plus 1. So here 1 is equivalent to as plus 2a plus bs plus b. So here in this case a is equivalent to 1 and b is equivalent to minus 1. So you can see that your constants are a s term. If I am going to equate, it is going to be your a plus b is equivalent to 0. So that means a is equivalent to minus b. Okay, the constant terms if I am going to take, it is 2a plus b is equivalent to 1. So b is nothing but minus a. So 2a minus a is equivalent to 1. So a is equivalent to 1 means your b is equivalent to minus 1. So that is what we have got here. So now we will substitute it. So when I substitute it, my expression is h of s f of s is equal to 1 by s plus 1 minus 1 by s plus 2. So if I take the inverse Laplace, it is going to be h of t convoluted f of t is equal to e power minus t minus e power minus 2t. So this is how you have to apply your convolution theorem and find out your convoluted value of the two signals here. Thank you.